May 12, 1940, 15:45 hours. Reich Chancellery, Berlin. Reichsmarschall Hermann Göring's laughter echoed through the opulent halls of the Reich Chancellery as he read the intercepted transcript of President Roosevelt's speech to Congress. The Luftwaffe commander, resplendent in his sky-blue uniform adorned with diamonds and gold braid, dismissed the American president's ambitious aircraft production goals with the casual arrogance of a man who believed his Air Force invincible. 50,000 aircraft annually, Göring scoffed to his assembled staff officers, waving the intelligence report with theatrical disdain. The Americans cannot even produce decent automobiles without foreign assistance. How do they expect to build military aircraft that can match German engineering? His words carried the confidence of a leader whose Luftwaffe had just crushed Poland, Norway, and was preparing to devastate France with unprecedented aerial warfare. The scene in Berlin that spring afternoon represented the pinnacle of German military confidence. Göring's Luftwaffe possessed 4,500 operational aircraft, manned by the world's most experienced combat pilots. German aviation technology led the world with revolutionary designs like the Heinkel He-111, Messerschmitt Bf-109, and experimental jet engines that promised even greater superiority. American aviation seemed primitive by comparison. Slow, outdated designs produced by an industry focused on civilian markets rather than military necessity. Follow our channel for more incredible stories that reveal how industrial determination and democratic resolve transformed the impossible into inevitable victory. Major General Hans Jaschonek, Luftwaffe Chief of Staff, shared his commander's confidence but possessed the technical knowledge that should have tempered such arrogance. German aircraft production in 1940 reached 10,826 units annually, impressive by European standards, yet requiring the full capacity of German industry operating under wartime conditions. The Americans spoke of producing 5 times that quantities while maintaining civilian production that Germans had already sacrificed for military necessity. The intelligence briefing revealed disturbing details about American industrial potential that Göring dismissed with characteristic hubris. United States Steel Corporation alone possessed production capacity exceeding total German steel output. General Motors manufactured more vehicles annually than all European automakers combined. Boeing, Douglas, and Lockheed were expanding facilities at unprecedented rates, suggesting preparation for production levels that defied German understanding of industrial logistics. Oberst Edgar Peterson, Luftwaffe intelligence chief, presented sobering analysis that contradicted his superior's optimism. American aviation companies were recruiting engineers from across the globe, including German expatriates who understood both American production methods and German aircraft designs. Training programs were producing pilots, mechanics, and technicians at rates that indicated systematic preparation for massive air operations, extending far beyond current American capabilities. The most ominous intelligence concerned American raw material access. Unlike Germany, which faced increasing blockade pressures that limited aluminum, steel, and fuel supplies, America possessed unlimited domestic resources plus global supply networks that British naval power protected rather than threatened. German aircraft production faced material constraints that would worsen as the war progressed. American production faced only organizational challenges that industrial expansion could solve. Göring's dismissal of American potential reflected broader German misunderstanding of democratic industrial mobilization. The Luftwaffe commander viewed aircraft production through the lens of traditional European methods, skilled craftsmen producing individual aircraft with meticulous attention to detail. American industry operated on mass production principles that prioritized quantity and standardization over individual craftsmanship, creating systematic advantages that German military leaders couldn't comprehend. As the meeting concluded, Göring issued orders that would prove catastrophically short-sighted. German aircraft production would focus on quality over quantity, maintaining technological superiority through advanced designs rather than expanded output. The Luftwaffe would defeat American air power through superior tactics and aircraft performance, making numerical advantages irrelevant through individual excellence that German training and equipment provided. But across the Atlantic, American industrial leaders were transforming Roosevelt's seemingly impossible production goals into systematic reality, beginning a mobilization effort that would eclipse German capabilities through sheer mathematical inevitability. September 15th, 1940, 0830 hours. Willow Run Plant Construction Site, Michigan. While Göring continued to mock American aviation ambitions from his luxurious Berlin headquarters, Henry Ford II stood in a muddy Michigan field watching the construction of what would become the world's largest aircraft manufacturing facility. The Willow Run plant, designed to produce B-24 Liberator bombers using automotive assembly line techniques, represented a revolutionary approach to military manufacturing that would transform industrial warfare forever. Ford's chief engineer, Charles Sorensen, explained the plant's unprecedented specifications to a gathering of aviation executives who struggled to comprehend the scale of American ambitions. The facility would span 3.5 million square feet under a single roof, employ 42,000 workers operating in 3 shifts, and produce one 4-engine bomber every 55 minutes once fully operational. Such production rates exceeded total German bomber output across all factories combined. The technical challenges seemed insurmountable by traditional aircraft manufacturing standards. Boeing's original B-24 design required 1.2 million individual parts assembled by skilled craftsmen over several months. Ford's engineers proposed breaking down construction into 15-minute assembly stations where semi-skilled workers could install standardized components with minimal training. The concept violated every principle of traditional aircraft construction, yet mathematical projections indicated it could achieve production rates that military necessity demanded. Across the continent at Douglas Aircraft in California, company president Donald Douglas Sr. faced similar challenges scaling up production of A-20 attack bombers and C-47 transport aircraft. His solution involved constructing satellite plants across the American Southwest, creating an integrated production network that could manufacture aircraft components in specialized facilities before final assembly at centralized locations. The systematic distribution of manufacturing capability would make American aircraft production virtually invulnerable to enemy attack. Meanwhile, in Seattle, Boeing's leadership team under President Philip Johnson was transforming their company from a regional manufacturer into America's primary producer of heavy bombers. The B-17 Flying Fortress production lines were expanding to accommodate orders that exceeded the company's entire pre-war output projections. Engineering teams worked 18-hour shifts, designing manufacturing processes that could produce complex aircraft with the efficiency of automobile assembly lines. The human element of American aircraft production revealed advantages that German intelligence services couldn't quantify. Rosie Chen welded aircraft components in California, while her husband served with the 442nd Regiment in Europe. Margaret Kowalski assembled electronic systems in Michigan, while her son flew bombing missions over Germany. American workers possessed personal stakes in production quality that transcended professional obligation, creating systematic attention to detail that mass production methods couldn't compromise. Training programs produced the workforce necessary for unprecedented production expansion. The government's War Production Training Program graduated 50,000 skilled aircraft workers monthly, transforming farmers, teachers, and housewives into precision manufacturers within 12 weeks. German aircraft production relied on apprenticeship systems that required years to develop competent workers. American training produced adequate workers in months while maintaining quality standards through systematic procedures. Raw material allocation revealed the mathematical impossibility of German competition with American production. The United States possessed 60% of global aluminum production capacity, 40% of steel output, and unlimited access to strategic materials through British protected supply lines. Germany faced increasing shortages of aluminum, chromium, and tungsten that forced substitution of inferior materials in critical aircraft components. The first production aircraft rolling off expanded American assembly lines in late 1940, demonstrated quality that matched traditional manufacturing methods while achieving production rates that exceeded German comprehension. Lockheed P-38. Lightning fighters emerged from California factories with performance specifications that rivaled German designs. Yet American pilots would receive them in quantities that rendered individual aircraft superiority mathematically irrelevant. Quality control procedures developed for mass production aircraft exceeded German military standards for precision and reliability. Statistical sampling methods identified defects before they reached operational aircraft. Standardized testing procedures ensured consistent performance across thousands of units. American aircraft might lack the individual craftsmanship of German designs, but they achieved reliability and performance through systematic methods that mass production made possible. As 1940 concluded, American aircraft production was approaching 20,000 units annually, while German output peaked at 15,000 units under maximum wartime mobilization. The mathematical trend lines were clear to anyone willing to acknowledge them. American production was accelerating, while German capacity faced resource constraints that would worsen as the war expanded. But Göring remained blind to the Industrial Revolution occurring across the Atlantic, dismissing production statistics as propaganda, while American factories prepared to demonstrate the terrible arithmetic of democratic industrial mobilization. December 7, 1941, 14:30 hours. Pearl Harbor. Attack aftermath. The Japanese attack on Pearl Harbor transformed American aircraft production from ambitious goal into desperate necessity, unleashing industrial mobilization that would dwarf even Roosevelt's optimistic projections. Within hours of the attack, American aviation plants received priority allocations for unlimited resources, labor, and materials that removed every constraint on production expansion except physical space and time. At Willow Run, now approaching operational capacity, Henry Ford's production teams implemented 24-hour manufacturing schedules that turned aircraft assembly into a mechanical symphony of precision and speed. The B-24 Liberator bombers emerging from Ford's assembly lines embodied American industrial philosophy: standardized components, interchangeable parts, and systematic quality control that enabled massive production without sacrificing performance standards. Göring's intelligence services, monitoring American production through neutral diplomatic channels, reported statistics that the Reichsmarschall dismissed as obvious propaganda. Monthly aircraft production figures from American factories exceeded German annual output, yet the quality of intercepted American aircraft suggested these numbers represented genuine manufacturing achievement rather than statistical manipulation for morale purposes. The confrontation between German aircraft technology and American production capacity became visible over European battlefields as increasing numbers of American-built fighters and bombers appeared in British service. Luftwaffe pilots reported engaging formations of American P-40 Warhawks and B-17 Flying Fortresses in quantities that indicated systematic replacement of losses rather than limited equipment allocation. Major Wilhelm Balthasar, Germany's leading fighter ace with over 100 victories, filed combat reports that revealed disturbing trends in aerial warfare mathematics. German pilots shot down American aircraft with technical superiority and tactical experience, yet replacements appeared faster than German forces could eliminate them. The Luftwaffe was winning individual battles while losing the statistical war through mathematical inevitability. At Boeing's Seattle facilities, production engineers achieved breakthrough efficiency by implementing Ford Motor Company assembly line techniques adapted for four-engine bomber construction. B-17 Flying Fortresses rolled off production lines every 90 minutes, each aircraft representing 400,000 individual components, assembled with precision that exceeded traditional manufacturing tolerances. American bombers achieved reliability through systematic production methods rather than individual craftsmanship. The psychological impact on German aviation leadership intensified as intelligence reports confirmed American production claims through captured equipment examination. German technical teams analyzing shot-down American aircraft discovered manufacturing quality that equaled German standards while showing evidence of mass production techniques that German industry couldn't replicate. The Americans had solved the fundamental challenge of combining quantity with quality through revolutionary industrial methods. Luftwaffe operational reports from the Russian front revealed the strategic implications of American aircraft production. Lend-Lease deliveries provided Soviet forces with American fighters and attack aircraft in quantities that compensated for massive Russian losses during the initial German offensive. American production was enabling Soviet resistance by replacing destroyed aircraft faster than German forces could eliminate them. In North Africa, German Afrika Korps units reported increasing encounters with American-built aircraft in British service. Curtiss P-40, Tomahawks and Bell P-39 Airacobras appeared in formations that indicated abundant supply rather than careful resource allocation. British and Commonwealth pilots flew American aircraft with casual confidence that reflected unlimited replacement availability. The technological confrontation reached crisis proportions when Luftwaffe test pilots evaluated captured American aircraft and discovered performance capabilities that challenged German assumptions about American engineering competence. The P-51 Mustang fighter, powered by British Rolls-Royce Merlin engines built under license in American factories, achieved performance specifications that exceeded German Messerschmitt Bf-10-9s while showing evidence of mass production that enabled unlimited numerical superiority. Quality control documentation recovered from crashed American aircraft revealed production standards that German aviation industry had abandoned under wartime pressures. American manufacturers maintained peacetime precision tolerances despite massive production volume increases. Statistical sampling procedures ensured consistent performance across thousands of units. Rejection rates for defective components exceeded German acceptance standards, indicating production abundance that enabled quality maintenance despite quantity emphasis. As 1942 progressed, German aircraft production struggled to reach 15,000 units annually, while American factories approached 48,000 aircraft yearly output. The mathematical impossibility of German victory in any prolonged aerial conflict was becoming undeniable to anyone willing to acknowledge production statistics over propaganda claims. But Göring continued to believe that German technological superiority and pilot training would overcome American numerical advantages, refusing to comprehend that mathematical certainty was replacing military strategy as the decisive factor in modern warfare. August 17th, 1943, 0900 hours. Schweinfurt Regensburg raid. The devastating climax of Göring's misconceptions about American aircraft production came during the combined bomber offensive against German industry, when 376 B-17 flying fortresses attacked ball-bearing factories at Schweinfurt and aircraft plants at Regensburg in the largest daylight bombing raid in aviation history. The mission represented not just tactical air power, but the mathematical vindication of American industrial philosophy over German technical precision. Brigadier General Curtis LeMay led the 4th Bombardment Wing toward Regensburg with grim determination that reflected the strategic reality Göring had refused to acknowledge. American aircraft losses, however severe, would be replaced by production lines that completed new bombers faster than German factories could manufacture the fighters needed to stop them. The arithmetic of attrition warfare favored the side with unlimited industrial capacity. Over Schweinfurt, Major Robert Williams piloted Memphis Belle III through concentrated flak that destroyed 60 American bombers in a single engagement. Williams watched German Messerschmitt Bf 109s and Focke-Wulf 190s attack with desperate courage, knowing each German fighter represented irreplaceable pilot training and manufacturing capacity that German industry couldn't sustain. American crews died heroically, but American factories would replace their aircraft within weeks. The human tragedy of the raid extended beyond combat casualties to the German pilots who fought with growing desperation against mathematically impossible odds. Hauptmann Egon Meyer, leading JG-2 Richthofen, achieved multiple victories against American bombers, while understanding that his tactical success was strategically meaningless. German aircraft production couldn't replace losses at rates necessary to maintain effective resistance against unlimited American numerical superiority. Technical Sergeant Dorothy Miller operated radio navigation equipment aboard the Yankee Doodle, coordinating bomber formations with precision that German pilots found incomprehensible. American aircrew training produced competent personnel within months using standardized procedures, while German replacement pilots required years of training that the Luftwaffe could no longer provide. Democratic industrial methods were creating human advantages that complemented material superiority. The climactic moment came when German fighters achieved devastating tactical success, shooting down 60 American bombers in the heaviest single-day losses of the air war. Yet Göring's monitoring of American radio communications revealed that replacement aircraft were already rolling off production lines to compensate for battle damage. American industrial capacity was absorbing tactical defeats and converting them into strategic victories through simple mathematical persistence. Oberst Adolf Galland, leading German fighter operations, filed reports that acknowledged the hopeless mathematics of aerial warfare against American production capacity. German pilot training programs produced 500 fighter pilots monthly. American training facilities graduated 3,000 pilots, using systematic methods that emphasized quantity over individual excellence. The Luftwaffe was engaged in attrition warfare against an enemy that possessed unlimited replacement capacity. American bomb damage assessment revealed the systematic destruction of German aircraft production facilities with precision that reflected industrial planning rather than military improvisation. Target selection prioritized ball-bearing factories, aluminum smelters, and engine plants that represented irreplaceable manufacturing capacity. American bombing strategy understood industrial warfare as systematic application of production mathematics rather than tactical air operations. The tragic irony became apparent through post-mission intelligence analysis. German aircraft production peaked at 25,000 units in 1943 under maximum wartime mobilization, while American factories achieved 85,000 aircraft annual output while maintaining civilian production that Germans had sacrificed for military necessity. The Americans were defeating German air power while operating at partial industrial capacity. Quality control reports from salvaged German aircraft revealed the material constraints that doomed Luftwaffe effectiveness, regardless of pilot courage or tactical innovation. German fighters used substitute materials that reduced performance and reliability. Fuel shortages limited pilot training and operational readiness. Ammunition rationing restricted gunnery practice that American pilots received without limitation. The psychological climax occurred when German intelligence services confirmed American production statistics through independent verification rather than intercepted communications. Boeing, Consolidated, Douglas, Lockheed, and North American Aviation were collectively produced aircraft at rates that exceeded total Axis output across all nations and all aircraft types. The mathematical impossibility of German victory was no longer debatable. As autumn approached, Göring faced the undeniable evidence that his mockery of American aircraft production had become historical tragedy. The United States had answered his scorn not with 50,000 aircraft annually, but with production approaching 100,000 units yearly, while maintaining quality standards that equaled German peacetime manufacturing under unlimited resource conditions. The heroism of individual German pilots and the tragedy of their inevitable defeat was becoming a mathematical equation rather than a military contest, where courage could not overcome production statistics that rendered resistance futile. May 8, 1945, 1100 hours, Mondorf-les-Bains prison, Luxembourg. In the Allied detention center where he awaited trial for war crimes, Hermann Göring sat surrounded by statistical reports that quantified the magnitude of his catastrophic underestimation of American industrial capacity. The final production figures told a story of mathematical inevitability that no amount of German technological sophistication or tactical brilliance could have overcome. The numbers were staggering in their finality. American aircraft production had reached 300,317 units in 1944 alone, surpassing Göring's mocked target of 50,000 annually by a factor of 6. Total American aircraft production from 1940 to 1945 exceeded 300,000 military aircraft, while maintaining civilian aviation manufacturing that Germans had abandoned entirely for military production. The industrial mobilization that Göring had dismissed as impossible had become the decisive factor in history's greatest military conflict. Colonel Harold Watson, the Allied intelligence officer conducting Göring's debriefing, presented production comparisons that revealed the mathematical impossibility of German victory from the moment America entered the war. German aircraft production peaked at 39,807 units in 1944 under maximum wartime mobilization, while American factories achieved 96,318 aircraft in the same year, while supporting British, Soviet, and other Allied air forces through Lend-Lease programs. The human cost of Göring's miscalculation became apparent through Luftwaffe personnel statistics that reflected systematic destruction of German aviation capability. The Luftwaffe had lost 57,137 aircraft in combat, with pilot casualties exceeding 28,000 killed and 25,000 wounded. German training programs couldn't replace experienced aircrew fast enough to maintain operational effectiveness against unlimited American numerical superiority, backed by systematic pilot training programs. Technical analysis of captured German aircraft revealed the material constraints that had doomed Luftwaffe effectiveness, regardless of individual heroism or tactical innovation. Late-war German fighters used substitute materials that reduced performance, synthetic fuels that limited engine life, and simplified production methods that sacrificed reliability for quantity. American aircraft maintained peacetime quality standards despite wartime production urgency. The strategic implications extended beyond aviation to demonstrate how democratic industrial mobilization had proven superior to totalitarian economic planning. American aircraft production had been achieved while maintaining civilian living standards that exceeded German wartime conditions. Workers had volunteered for extended shifts rather than being coerced through political control. Innovation had emerged from competitive commercial development rather than centralized state direction. Göring's final interviews revealed a broken man who understood too late that mockery of American industrial potential had been based on fundamental misunderstanding of democratic society's capacity for voluntary mobilization. "I could not have imagined," he admitted to Watson, "that a nation of shopkeepers and farmers could transform itself into the world's greatest military-industrial power within 5 years." The legacy extended beyond aircraft production to influence post-war aviation development and strategic planning. American aircraft manufacturers, Boeing, Douglas, Lockheed, and others, had developed mass production techniques and design capabilities that would dominate global aviation for decades. The systematic methods that had produced 300,000 military aircraft would revolutionize civilian aviation and aerospace technology. Personal stories from American aircraft workers revealed the human foundation of industrial achievement that Göring had failed to comprehend. Rosie Chen had welded bomber components while her husband fought in Italy. Dorothy Miller had assembled electronic systems while her son flew missions over Germany. Margaret Kowalski had manufactured aircraft engines while her brother served in the Pacific. Democratic values had created personal motivation that totalitarian systems couldn't replicate. The mathematical certainty of American victory had been apparent to qualified observers by late 1942, when production trends indicated inevitable Axis defeat through industrial attrition. German resistance had continued for 2 additional years due to political rather than military considerations, prolonging conflict that production statistics had already decided. Industrial capacity had replaced military strategy as the decisive factor in modern warfare. Quality control documentation from American aircraft plants revealed production standards that had exceeded German peacetime manufacturing despite unprecedented quantity requirements. Rejection rates for defective components had remained lower than German acceptance standards throughout the war. Statistical sampling procedures had ensured consistent performance across hundreds of thousands of aircraft. Mass production had achieved quality through systematic methods rather than individual craftsmanship. Follow our channel for more remarkable stories that reveal how industrial determination, democratic resolve, and systematic planning combined to achieve victories that seemed impossible until mathematics made them inevitable. The symbolic legacy remained forever captured in a single statistic. American aircraft production in 1944 alone exceeded total German aircraft manufacturing from 1933 to 1945. Göring's mockery of 50,000 American aircraft had been answered with 300,000 aircraft that redefined industrial warfare and established American aerospace dominance for generations. The laughter that had echoed through Berlin's Reich Chancellery in 1940 had become historical footnote to the greatest industrial achievement in human history, proving that democratic determination could transform impossible dreams into mathematical certainties that reshape the world.